Hi, everyone. Thanks for tuning in. I'll start by introducing myself. So I'm John Adiojo, founder and chief data scientist at Data-Centric Solutions. I'm making this video today just to show you how I've started to reimagine the recommendation engine. What's prompted this is a lot of the innovations we've seen in the natural language processing space, specifically with the large language models that have come out, and also the frameworks around them that allow you to stitch these models together to form more complex chains that can perform more complex tasks. So when we think about reimagining the recommendation engine, it's probably best to take a step back and look at how we currently interact with web applications or with content online. There are a few methods that we currently use today to do that. The first one is probably the most obvious one, the Google search engine. We're all familiar with that, and that's probably where the majority of our queries for online content go through. The second is the old school traditional website static menu. So you visit a website and somebody has meticulously crafted a menu where you can select different options to navigate our website and decide what information you need. The third is the newsfeed. Now, this is powered by the traditional recommendation engine that we've all become accustomed to. And the idea behind that is to recommend you the content that it believes, or the algorithm behind it believes you will enjoy the most. Really, what's happening is it's recommending you what you will engage with the most. And off the back of that, we've actually seen a lot of negative impacts of recommendation engines. There's some biases reinforced there, because if you look at recommendation engines, it seems like there's a lot of negative content coming up on news feeds. And I believe that's because those recommendation engines are geared towards engagement. And the things that cause the most engagement are pieces of content that are controversial, because people argue in the comments, and interaction with comments is a metric for engagement for a lot of these algorithms. Now, I talked briefly about reimagining the recommendation engine, and I'd like to get into that a little bit. With large language models and the generative AI and the frameworks around them that we have access to, there is the potential now to have an AI assistant as a sort of recommendation engine. Now, how would that work? I think it's best to talk a little bit around an example that illustrates this well. So I'd like you to imagine for a second that you are taking a trip, you're on vacation somewhere. Let's just say you're on vacation in Iceland. You're in the capital city, Reykjavik, and you wish to see the Northern Lights. Now, I don't know how many of you have been to Iceland before, or whether you know anything about Northern Lights, but it's not something you just see by fluke. There has to be a lot of planning and preparation. The weather conditions have to be right, and you have to turn up at the right time of year, right time of day, under the perfect conditions, and you may get to see them. I think actually a lot of tour companies will give you a guarantee that if they take you out to see the Northern Lights and you don't get to see them, you get to do that journey again for free. So if you're in this position, you're in Iceland and you want to go and see the Northern Lights, what you may do is put something into Google as a first port of call. I'd like to just take you through that just to illustrate the example here. So I have a search already pre-written just to save some time here. And all we're saying here is, I'm visiting Reykjavik. Please recommend me the days I'm most likely to see the Northern Lights. I might add in the coming week just to make this more precise. So if we take that and paste that into a Google search, we don't really get a recommendation. What we get is a bunch of websites with generic content about when it's best to actually go and visit Reykjavik to see the Northern Lights, or when it's best to be in Iceland to see the Northern Lights. These are general principles. They do work well, but they don't actually answer a specific question. There's no recommendation here at all, really. And granted, that isn't what the Google search engine or search engines in general were designed for. But how has generative AI changed this? Well, now it's possible because what we can do is we can take this natural language query and run it over some structured data about weather patterns and get the generative AI model to return to us an answer that it thinks is the most suitable time to visit Reykjavik to see the northern lights. So let's put this into action and see how it works. Paste the query in here. As you can see, it's the same query we use in Google. And I'll hit submit. So we have a response back here, and the response says the best day to see the northern lights in Reykjavik in the coming week are July the 19th, 15th, and 18th. The weather conditions for these days are mostly clear skies, low humidity, low wind speed, and no rain. The temperature will range from 6.66 degrees to 11.49 degrees, and the field slight temperature will range from 4.78 degrees to 11.07 degrees. That's quite a detailed answer, and that's a good recommendation, I would suggest. So let's have a look at what's happening behind the scenes, or step into the script. And what you can see here is the engine, the application that I've developed, has actually managed to take our text query, our natural language query, and convert that into a SQL query using some analytical logic. So what's it done? So we've selected the variables that we need to consider from our weather data. The location has been selected as well as Reykjavik, and that's been pulled from the Open Weather API. And then we've ordered by a variable POP and limited 5. So it's just taking the top 5 days. And what the generative AI has managed to do is select the best days from that query. So that's the logic that the generative AI has come up with in order to select the best days to visit Iceland to see the northern lights. So let's take a step back and try to understand how this is all possible and how it's working. There's two main innovations really behind this, or 3 main innovations really behind this. The first one we've already talked about, which are the large language models. So in this particular case, we're using GPT-4 as the large language model for these queries. The second innovation is actually from Langchain, which is the SQL. Sorry, the second innovation is from OpenAI, not Langchain. That is the OpenAI function calling. That's a recent innovation that means that what we can do with natural language has become a lot more flexible. So with function calling, it allows us to take a natural language query and generate arguments from that query. So for our particular use case here, which is extracting recommendations about travel destinations that we want to go to, so weather AI assistant, what we need to do first is understand where we want the weather for, where we want to know what the weather forecast is like. The user puts it in a natural language query, I'm visiting Reykjavik. What function calling allows you to do is take that query and extract the location argument from that query. And that location argument would have been defined in a function that you already had set up. The second innovation, or the third innovation actually, is the SQL database chain from Langchain. What that allows you to do is take a natural language query and turn it into a SQL query that can be used on a structured data set. End to end, the whole thing looks like this. The user puts in a natural language request. The function calling API pulls out the arguments for the location. That's sent to a GeoPy API, and that pulls the longitude and latitude for that location. That's then sent through to the Open Weather Map API, which pulls the weather at that location for the next 5 days. Once we have that, then we can use Langchain's SQL database chain with the initial natural language input and generate an automated SQL query on that data to answer our question. And then the response is what you see on screen. In short, what I think we can deliver here is more personalized recommendations that, fit specific purposes. So this is just an example with weather, but in theory, you could extend this to different things like booking hotels, booking flights, holidays, restaurants, you name it, anything where you need some advice on where to go or you need a recommendation. It would be like asking a friend, but that friend has an extensive data set behind it to back the recommendations. There are obviously a few kinks to iron out with this type of software. So this is a prototype that I've developed, but if you were to imagine scaling this, there are a few issues that I foresee. So the first one is the latency. It still does take quite a long time to respond to a query. Now, obviously, anyone that wants to use this as a product would have to consider that, because I think engagement levels will slip if the latency remains quite high. So there's a lot of work to be done with large language models to try and speed up that latency. And the issue here is that the GPT 3.5 Turbo, which is a faster model, is not as performant for this task than GPT-4. Granted, with a bit more feature engineering, maybe it could get to that level of performance for this particular task, but just out of the box, it's not as performant. So we accept that there is a little bit of a slip in latency here. The second thing to consider is the cost. Now, every time you query OpenAI, every time you send a request to OpenAI, you pay for that. Now, I don't know the cost offhand, but what I do know is that once you scale this to hundreds, thousands, millions of users, that cost is going to accumulate very quickly. With each user sending multiple requests every time, scaled by the number of users you have, you can imagine that the cost runs away quite quickly. So the applications that this is suited to at the minute have to have the real commercial value behind them. There has to be some kind of revenue generation at the end of it that will account for those costs. Otherwise, it's probably not worth it for that, to go with this approach. You probably could use some alternative, some open source alternative that doesn't cost you money to query, but I think it won't be as performant, and you'd have to find a way to replace the function calling functionality that OpenAI give you. Another thing to consider here as well is that large language models do have the capacity to hallucinate. And this applies across every area they use. So even with the SQL database chain there, SQL is it's a structured language, but the large language model has to decide the logic in which it uses to create the SQL query itself. As far as I've used it so far, it's been pretty good, and it's been quite spot on with the logic it uses to decide what query to write. However, scaling this again to millions of users, you can imagine that sometimes it's going to get it wrong. And when it does get it wrong, you want to make sure that it's not devastating to the user. So that's something to think about. How do you make it so that the large language models, what they deliver, the results they deliver are robust, such that there's a bit more control and there are less hallucinations. Now, there are papers on prompt engineering methods that have been presented that actually can make the responses more robust. And that might be worth looking into if you're planning to use these large language models at scale. So I have written a technical blog post on this prototype and on the topic of reimagining the recommendation engine. That will be available in the description of this video as soon as it's published. I have also productionized this application for you to use and experiment with yourself. You will need an OpenAI API key to use it, and that's absolutely fine. You can get one for free. I think they offer a free tier, and I don't think this application should use too many tokens. Although on the back end, it is operating off GPT-4 now, so there might be issues if you don't have access to GPT-4 yet. So that's something to bear in mind. And that's it pretty much. I think I'm personally impressed with the frameworks that have been delivered by OpenAI. They've been delivered by OpenAI and Langchain. I think they work well from what I've used already. I think there's a long way to go before. I think there's a lot of innovation and development that needs to happen before they are really commercially solid projects, but that is happening at pace, which is fantastic to see. As I said before, if you want to get into a bit more of the technical details, the code behind this, how to build your own, that's all going to be in the technical blog post that I've written up, and that's linked in the description of this video. So feel free to check that out. Feel free to like, comment, reshare, give us your opinions on what you think about this reimagining the recommendation engine. Give us your opinions on large language models in general, where you see the field going, where you see the products going, any other creative use cases that you see. I would love to hear about in the comments, and other people would as well. So please drop us your opinions on that. Thank you for tuning in, and I hope you enjoyed this demo.